My name is Amit Kumar. I have 20-year experience in engineering and construction industry in diverse function. Today I am going to explain about basics of coal handling plant. Power plant and steel plant are two areas which utilizes coal as the raw material. These two plants uses coal in a very bulk quantity. So a large size of coal handling plant is installed in power plant and steel plant for handling the coals. There are different processes involved in the coal handling plant: unloading of coal, conveying of coal, screening of coal, crushing of coal, stacking of coal, reclaiming of coal, storing of coal, and finally coal is fed to the user plant. Now, what are the design inputs for the coal handling plant? Grade of coal is most important to design the coal handling plant. Transportation mode of coal, whether coal has to be transported by rail or road or sea route, that is also very important from the design point of view. Wind velocity and seismic zone, that is important for designing the structural part of the coal handling plant. Source of water, whether water will be sourced from the river or any other sources, what is the distance of river from the plant. So these are the basic inputs which are required for designing any coal handling plant. Now, what is the terminal point of coal handling plant? Coal handling plant basically starts from unloading of coal. Unloading of coal is done by either wagon tipper or track hopper. And finally, coal has to be fed in the coal bunker or coal silos. So these are the two endpoints of coal handling plant. These are the major packages of coal handling plant: conveyor package, machine package, dust separation system, water system, bulldozer package, air conditioning system, ventilation system, firefighting system, dust extraction system, and finally electrical and automation system. What are the major equipments of coal handling plant? Track hopper is one of the most important equipment of coal handling plant, where coal is brought by the means of railway wagon, and there will be number of concrete hoppers in the track hopper, where coal will be unloaded from the bottom opening wagon of the rail. There will be a water dust separation system also, because while unloading the coal there will be huge amount of dust emission. So that dust is suppressed by plain water dust separation system. Below the track hopper there will be a paddle feeder. This paddle feeder is used for taking out the coal from the hopper, and it will be fed to the conveyor. There will be also a belt weigher on the conveyor to measure the coal received from the track hopper. I am taking the example of Yadadri thermal power plant, where we have installed 1875 MTPH paddle feeder. There are 4 number of paddle feeder here, and this paddle feeder can travel across the complete track, which is of around 400 meters. There is a wagon tipper also, which can be utilized for unloading of the coal. But unloading mechanism in wagon tipper is different from the track hopper. In track hopper there is a bottom opening wagon. In the wagon tipper it's a top opening wagon. So wagon tipper is designed to unload the top opening wagon, and there is a tippling operations. The storage capacity of Yadadri thermal power plant wagon tipper is around 300 ton for each hopper of the wagon tipper. There is a side charge arm also along with the wagon tipper, which is used for placement of wagons on the tippler table. And once wagon is unloaded, this empty wagon is removed from the tippler table after tippling by the side arm charger. Apron filter is also very important equipment, which will be at the bottom of wagon tippler, where coal from the wagon tippler hopper shall be evacuated by this machine, apron feeder, along with the dribble conveyor. From apron feeder it will further fed to the conveyor below the apron feeder. Here also there will be belt weigher to measure the coal received from the wagon tippler. Apron feeder rating in Yadadri thermal power plant is 2500 TPH. In coal handling plant, we install suspended magnet, metal detector and inline magnetic separator. Suspended magnet is used for removal of metallic parts from the coal. Normally suspended magnet is installed in penthouse. Metal detector is also installed on the conveyor to detect any metallic or non-metallic element in the coal, because these elements can damage the crusher. So these has to be eliminated before feeding the coal into the crusher. Inline magnetic separator is also installed on the conveyor head end for removing the metallic tramp from the coal. This coal will be fed into the crusher for crushing the coal. Before crushing the coal is fed to the screen, or this is also called vibrating gauge feeder. The rating of VGF is 2000 TPH in Yadadri thermal power station. Here basically raw coal of around 300 mm will be received, and the screen will basically screen out 20 mm coal to the crusher, and less than 20 mm coal will be fed to the belt feeder directly. More than 20 mm coal will be fed to the crusher for crushing the coal, because the coal size has to be less than 20 mm for feeding in the coal bunker. Now there is a crusher also below the screen which is used for crushing the coal. So now in the crusher, huge amount of dust is generated during the crushing and during the feeding of the coal from the screen also to the crusher. So here also a dust extraction system is installed, where dust is extracted from the crusher building. There is a dry fog dust suppression system also in the building for suppressing the dust while feeding the coal from the screen to the crusher. After crushing the coal, this coal has to be stored at certain location. Normally it is stored at the stockpiles. So there is a machine called a stacker which is used for stacking the coal in the stack pile. In Yadadri thermal power plant, we have 3 number of stacker and 3 number of reclaimer. Rating of stacker is around 2500 TPH here. There is a boom in the stacker which can move 105 degree from the center line of the yard conveyor in both the directions. The boom length is approximately 41 meter. So this stacker will basically stock the coal at a height of approximately 10 meter. There is a reclaimer also which can reclaim the coal from the stockpile, and it can be fed to the conveyor. In the stockpile, we have a storage capacity of approximately around 7.5 lakh metric ton of coal, which can be utilized for 11 days for smooth operation of the plant. There is a RCRH also, that is called raw coal emergency reclaimer hopper. In raw coal emergency reclaimer hopper, raw coal is fed, and this is further brought to the conveyor. We have also emergency reclaimer hopper where crushed coal can be directly fed, and through emergency reclaimer also we can take out the coal and it can be conveyed through the conveyor system. We have around 8 number of hoppers in RCRH whose capacity is around 400 TPH. In emergency reclaimer, we have 4 number of hopper whose capacity is around 500 TPH. There is a dozer shed also where dozer is kept. This dozer is used for dozing the coal into the reclaimer hopper. There are fixed tripper also at many locations. This fixed tripper are basically used to trip the coal at certain locations. We have a traveling trapper also in the coal bunker where the coal is fed to the different bunker depending on storage level of the bunker. So there is a traveling tripper which can move across the bunker. Each boiler building, we have 2 number of bunker floor. In each bunker floor, there will be 2 number of truck tripler. In coal handling plant, there will be many transfer point and many conveyor. This conveyor will basically used for conveying the coal through the belt conveyor mechanism. There will be a transfer point where the drive of the conveyor will be kept, or it is the junction where the direction of conveyor can be changed. In a thermal power station, the maximum build capacity is 2500 TPH. Maximum width of belt is 1800 meter. We have around 80 number of conveyor here. The total length of the conveyor is approximately 23 km. In this power plant, we have also installed dust separation system. In all the junction tower, dust separation system installed where dry fog kind of dust separation mechanism is used for suppressing the coal. We utilize plain water dust separation system in wagon tripler, track hopper, ERH and stockpiles. Coal bunker and crusher house are 2 places where huge amount of dust is also generated. So here dust extraction mechanism is also there. So we have installed right type dust extraction system in coal bunker as well as in crusher house. In all the MCC control room, there will be air conditioning system because advanced DCS control system will be installed there. Large number of PC engineering stations, large video system will be installed there, which require air conditioning system for proper operation for a long time. There are many areas in the coal handling plant where air circulation is bad, like all the underground buildings, tunnels, MCC rooms. Here we basically require the ventilation systems. In all the tunnel, we have a supply and exhaust ventilations. In MCC room, there will be evaporative cooling system with air filtration units. And bunker bay also, there is exhaust fan for the proper ventilations. In coal handling plant, it has to be completely wired, and there is a large amount of automation involved here. So huge electrical component is involved. In coal handling plant, we install transformers, switchgear, cables, ST motors, DC systems, 3D level sensor for stockpiles, cable tray and accessories, earthing, lighting, illumination, battery and battery charger, welding sockets, distribution board, transmission. So complete electrical system is installed in the coal handling plant for automating this coal handling plant. Huge C&I system is also involved in this coal handling plant. I'm just sharing you photographs of Kottagudem coal handling plant, which has been installed by Bharat Heavy Electrical Limited. This is a overview of coal handling plant of Kottagudem thermal power station. This is a bunker gallery which is feeding to the bunker of the boiler building. Then there is the apron feeder. This is below the wagon tipler. This is a mobile tripper on the bunker galleries. This is a typical coal handling plant layout of Yadin thermal power stations, where you can see that coal is brought either from the track hopper or wagon tipler. Coal is unloaded either a track hopper or wagon tipler. Then coal is fed to bunker through different conveyor. There are almost 8 number of stockpiles for stocking the coals. Then different machines are installed here at the different locations. Now I am sharing raw material handling system of NMDC, which has also been installed by Bharat Heavy Electrical Limited. This is a material flow sheet of NMDC steel plant, where you can see that coal is one of the largest raw material required for the steel plant. This coal is fed in the coke oven, where coke is formed, and this coke is finally fed to the blast furnace, where pig iron is created. This pig iron is fed to the BOF or steel mill shop, and from there crude steel is generated. This is the typical layout of material handling system of NMDC raw material handling system. There are 8 routes involved in this raw material handling system of NMDC steel plant: coal route, coke route, sinter product route, ore route, sinter feed route, CDI route, LDCP and assessments route, slag route. These are the few photographs of NMDC raw material handling system. This is the wagon tipper complex of NMDC steel plant. These are the stacker claimers. This is a coal silo where coal is stored. So thank you so much. I will come again with such kind of useful presentations. Thank you once again.